So now based on that concept, so just whenever they given a real part, the harmonic conjugate is nothing but just finding the imaginary part of that one. For the above function, find its harmonic conjugate, u of x comma y. Okay, so just I'll explain this function, how to find out the harmonic conjugate of that function. So after that, you can do more problems based on that. So the function is same, e power x cos y. Wait a minute. Okay. The function is e power x cos y. They are given the real part. Harmonic conjugate means just you have to find out the imaginary part. So that means by using either you can find out what's that by finding the function also you can find out the harmonic conjugate, otherwise directly also you can find out. So for both the methods, the only common thing is you should use the CR equations, right? So now first you wrote down the function u equals e power x cos y. So now we have to find out the imaginary part. What will be the imaginary part corresponding to the function u? So they are given the function, what's that? U is a real part of an analytic function. So since they are given real part of an analytic function, since u is the RP of analytic function, RP of an analytic function, right? So that's why definitely it will satisfy the CR equations. Dou u by dou x equals dou v by dou y, and dou u by dou y equals minus dou v by dou x. So you have to find out the partial derivative of the given function with respect to x and y, yeah, and then you have to substitute. What will be the dou u by dou x? It will be e power x cos y, which is equals to dou v by dou y. And dou u by dou y will become minus e power x sin y, which is equals to minus dou v by dou x. So just to cancel minus minus sign. So now you have to integrate this first equation with respect to y, and this one you have to integrate with respect to x. So just to integrate first one with respect to y. So if you integrate this one with respect to y means first I'll write the v, which is equals to e power x cos y. The integration of e power x cos y. Whenever you are going to integrate with respect to y, you have to treat x as constant. Here also same rules will be. E power x into integration of cos y is what? Integration of cos y.
Minus sin y.
Sin y, right? For x sin y plus function f of x. Okay. So now second equation you integrate with respect to x. So then v equals to the integration of this one will become e power x sin y plus g of y. So now you equate these two equations. So then you get the function of x and g of y. Is there any function of x alone in the second equation? V equals e power x sin y plus g of y. Is there any function alone in terms of x?
No, sir.
So that means f of x equals 0. Understood how to find out the f of x? F of x is nothing but integrating constant. Okay. So now, is there any function of y alone in the first function, first equation?
No, sir.
That means g of y also 0. Otherwise, how we can write?
Sir, if x plus e power x sin y means there will be 1, sir.
1 minute, Vignesh.
Okay, sir.
Yes, Vignesh.
No, sir. When it will be in f of x will be not 0, sir, in that v function.
For example, in the second equation, if you got e power x sin plus x square plus g of y.
X square. Okay, sir. Okay.
Okay. So here,
Yes, sir.
x square is nothing but what? Function of x, x alone. Right?
Yes, sir.
So then f of x will be equals to x square. Otherwise, one more method I will tell. How we can write now? Whatever the common thing will be there, that thing you have to note down only once. If the function is repeated, okay, you have to write only once. You should not write both. So any function apart from that which is not repeated, that also you write once. Then that will become the required function. Understood?
Yes, sir.
So that's why the function required function v will be equals to e power x sin y. Is it clear? Is it clear? Kirtana?
Yes, sir.
Okay. So now
Yes, sir.
in case the same function u equals e power x cos y is same function, and if they asked us to find out the f of z, in case if they asked us to find out f of z means, in that case also you can continue with the same method. After finding the imaginary part, just you have to write u plus iv. We know the function u, that is e power x cos y plus b value we got it, so that is e power x sin y. So that will become e power x is constant. I'll take it out. Remaining thing is cos y plus I sin y. Right. Cos y plus I sin y, which is equal to, in place of cos y plus I sin y, what we can write? E power x into e power iy. So that will be equals to e power x plus iy. E power x plus iy means e power z. Okay, so this is the one of the method to find out the function f of z by finding imaginary part of the function. Is it clear this method? I'll tell one more method how to find out the function directly. Is this
Yes, sir.
clear how to find out the function by finding imaginary part?
Yes, sir.
Okay, so just one more method I'll tell how to find out the function alone. So if u equals e power x cos y, and if they ask us to find out f of z, what is f of z means? First what you have to do means, so just to consider the function in the form f of z equals u plus ib. Okay, so just to differentiate this one, because we don't know the value of v, so that's why you differentiate, because we know if u is the real part of the analytic function means we can express that first order derivative of v in terms of u. For that purpose, you have to differentiate this one. So f of z means that is a composite function. The derivative of f of z is f dash of z, and derivative of z with respect to x, dou z by dou x, which is equals to u is a function of xy. That means it will become dou u by dou x plus I into dou v by dou x. So now z equals x plus iy means the derivative of z with respect to x will become what? 1, right? So that's why this will become
Yes, sir.
f dash of z equals dou u by dou x plus I into dou v by dou x. But now we don't know what's the function v. So without knowing the function v, we can't find out dou u by dou x directly. So that's why you have to use the CR equations. In place of dou v by dou x, what we can write in terms of u? What we can write?
In place of which one, sir?
Dou v by dou x, because dou v by dou x means you can find out.
That's what,
In
sir. We
place
can
of
write for x into cos y only. Do u by dou
Minus
x.
dou u by dou y you can write. Dou u by dou x minus I into dou u by dou y. Since we know the function u, so we can find out with respect to x dou u by dou x as well as dou u by dou y you can find out. After finding dou u by dou x and dou u by dou y, just you have to put x equals z and y equals 0. So and then you have to integrate with respect to z. Just to find out the values, dou u by dou x is what? E power x cos y minus I into dou u by dou y is minus e power x sin y. So that means it will become minus I into e power x sin y. Right? Just I substituted the value of dou u by dou x and dou u by dou y. Is it clear? Is it clear?
Yes, sir.
So after
Sir.
substituting dou u by dou x and dou u by dou y in terms of x and y, just you have to put x equals z and y equals 0. X equals z and y equals 0. So that means f dash of z will be equals to e power z into, what's the value of cos 0? What's the value of cos 0?
1, sir.
Value
Cos it is 90 degree, na?
cos 0 is 1 and sin 0 is 0, right? So that means it will become only e power z. F dash of z equals e power z. So now you integrate this one with respect to z. Integrate with respect to
Oh, this is okay.
the integration of f dash of z is f of z, which is equals to e power z plus z. So this is the required analytic function, right? Understood?
Yes, sir.
So from both methods, we got the function, same function, f of z equals e power z only. Either you can go through that, which one, by finding the imaginary part, you can find out the real, what's that analytic function, or directly by using the CR equations, that is derivative of that function, you can find out the analytic function. Understood?
Yes, sir.
Yes, sir. To find in CR equation, we have to do
Yes,
f dash
CR
of z.
equations
That
play a main crucial role. Whatever,
okay.
till integration, it will play a crucial role. CR equations.
Fine, sir.
Once if we enter into integration, somewhat different concepts we will study. So up to that, CR equations is very important. So just I'll take the attendance, answer the attendance, 10th and 11th, both based on this finding the analytic function only. Otherwise, I'll share this PDF later also, you can do it.
Okay, sir. You share the PDF, sir.
Questions based on that one only. A real component of sine hyperbolic, just to see this one, 12th one, sine hyperbolic of Ez means e power z. First you have to write e power z as e power x plus e power x plus iy. E power x into e power iy. E power iy, we can write that one as cos y plus I sin y. So just to separate the real and imaginary part, then we'll get the real component of the sine hyperbolic of e power.
Sir, like sin nh e power x, then
Not sine
sin
nh, it
nx
is
e
sine
power.
hyperbolic, sine h,
Okay, sir.
sine hyperbolic function. So this one based on once again it's finding the f of z, the same thing. Just you have to find out the dou u by dou x, dou u by dou y. After that, so I think this is the right direct question. So just you tell me what's the option for this one, right option.
Yes, sir. We'll show that.
So these type of direct questions you should
1 minute.
within a fraction of seconds.
Sir, D, sir.
D is the right option. Others?
Option D only, sir.
D only. Yes, exactly.
Option D, sir.
Option D is the right option. So next thing is complex integration. So whenever the function is real valued function, so we can integrate that one with respect to x, whichever variable will be there, that one we can integrate it directly. So, but if it is complex valued function, then you have to separately, you have to integrate real part as well as imaginary part. Separately, you have to integrate to find out the integration of any complex valued function. So, but it's very difficult to find out the complex integration to apply the complex integration, whatever integration to the complex valued function. So that's why we are going to study some few standard theorems. Based on standard theorems, we will try to evaluate the integrations. So, and one more thing, the main use of this studying complex integration is, so we can, by using this complex integration, we can evaluate some difficult improper integrals. In case if you are not able to find out the solution of any improper integral, so that type of integrals even you can solve by using this complex integration method. The main concepts in this one, main theorems in this complex integrations are, one is Cauchy's theorem, second one is Cauchy's integration theorem, and third one is very important one, Cauchy's residue theorem. So what is this theorem? Cauchy's theorem says means, if the function is analytic everywhere inside the given region, if it is analytic everywhere inside the whatever we are going to integrate in the region, in that region, if it is analytic means without finding the value of that function, directly we can write that value of the function will be 0. So that will say, this Cauchy's theorem will say that thing. If the function is analytic everywhere in the domain of integration, then it will be the integration of that function in that region will be 0. And the second theorem, Cauchy's integral formula. Cauchy's integral formula means, in case if it is not analytic at some particular point, only 1 or 2 or 3 points, so in that case you can go through this integral formula. So here just you observe z equals a is the non-analytic point. At the point z equals a, the function is not analytic. So then you can use in case if you want to find out the f of a or f of z by z minus a, just you can use this one 2 pi I into f of a. So that will become the required function. In case in the numerator whole square is there means, then you have to find out f dash of a, 2 pi I into f dash of a will become required value, 2 pi I by into f dash of a by 1 factorial. So if it is z minus a whole cube is there, it will become 2 pi I into f double dash of a by 2 factorial. Like this it will continues. And residues theorem means you should know what's that poles, what will be the singularities, poles of the function. If you know the poles, so at the poles you have to find out the residues. Okay, at the poles you have to find out the residues. So by using that one, we'll solve what's that Cauchy's residue theorem. So just to see here, the coefficient of z minus a whole power minus 1. Z minus a whole power minus 1 is nothing but the coefficient you will get some a naught a anything. So that coefficient we call it as pole. At that point, at the pole, the residue will be given by, so this is the formula, residue of f of a equals limit as z tends to a, z minus a into f of z. So this is the residue formula. Once if you find the residues, so just you can, what's that residue theorem you can apply, that is integral over f of z dz equals 2 pi I into sum of the residues. Okay, so just I'll continue in next week.